Okay, we are ready for section 1.3. We are going to talk about linear functions, slopes, and then as you work on the homework problems, you're going to see some application. Hopefully you're printing off the notes. If you are, you'll see that I'm using those here. I pre-populated some of them this time. I think that's going to help a lot as we go through with me not having to switch back and forth between the pen and the keyboard. And so the purpose here is if you print these off from Blackboard, you can fill the blanks in and work the problems along with me. We have some graphs in this section that you can graph with me. And then when you're ready to do your homework, you have a really nice set of like a summary of what all this section is about that I think is going to be very helpful. And also, as you study for quizzes and tests, you have something that has a nice summary for you to review. Okay, so let's go ahead and get started. Notice we're talking about linear functions. So just a really quick review. Let's talk about what functions are. So we started with talking about relations where we have two sets, and I'm going to just say numbers. It doesn't have to be numbers, but for this class, for the most part, we're talking about numbers. Two sets of numbers, and you have some kind of a mapping between them. That's a relation. It's a function whenever for every point or every number in the first set of numbers, there is exactly 1 point or one number in the second set of numbers. And when we're talking about ordered pairs and graphing these on a two-dimensional graph, we're calling the first set our x's and the second set our y's. So that means for every x that you pick, there's exactly one y. And then we looked at a graph of that means that if you pick any value as you go across your x-axis and you go up and down, you're going to have only one time that crosses your graph. There's only 1 point on there, and that's our vertical line test. Now, in this section, we're going to focus on linear functions. Now, not all functions are lines. Or they might be curved lines, they might be disconnected, they might be just a set of points. Linear functions are when you have a set of x's and y's that when you connect those ordered pairs, you get a straight line. So that's what we're focusing on in this section is functions that are straight lines. Okay, a couple definitions here in this very first sentence. A constant, so write that in, a constant is a value that doesn't change, while a variable can take on different values. So those two words might be very familiar with you. To you, they might not be. Constant, the words themselves kind of indicate what they mean. So an example of a constant would be any number, like the number 2. The number 2 is a constant because when we use the number 2, it means a certain value. It doesn't change. It could be 1/2, 3/4, 0.75. Those are all constants. But it can also be it can also be a letter or a symbol that represents a constant, something that doesn't change. And we're going to see that today, where we're using a letter to represent a constant. On the other hand, a variable is typically a letter or a symbol that can take on different values. So we're not meaning a single value whenever it is a variable. So it's kind of important to understand the difference of those two as we go on. Okay, the next sentence, let's dive into the equation for a linear function. A linear function can be written as f of x equals mx plus b, where m and b are constants. So this is an example where we are using letters to represent constants. So basically what this is saying is if you can rewrite an equation as f of x, and remember f of x is just a kind of a fancy way of saying y. It's just a way that we represent that second value, that y value, with some symbols to where if we can replace that x with a number, that tells us we've replaced the x with the number all the way through it. So I'm just going to read this as y equals. If we can rewrite an equation as y equals a number, because remember we said m is a constant, times x plus another number. So if you solve an equation for y, and this is what you get, y equals, and you have two terms. One is an x term and one is a constant term. And so the m and b are numbers. If you can do that, then you know it's going to end up being a linear equation. So when we talked about linear equations in 1.2, I said you're going to learn how to tell. This is how you tell. Solve it for y, and it has to fit this format. If it can fit this format, then you know you have a line. Now, the m and the b do have special meanings when we're talking about lines. So the m is the slope. And, you might say, well, why are we using m for slope? And the answer is because we always have. It's just been passed down for years and years. And I did a little looking as to why we use m, and most people think it comes from, I think there's a French word that starts with m that means slope, but we don't really know. It's just been passed down, year after year. So it might not make a really good connection with you at first. So just keep telling yourself m slope. M is slope. Our English word for slope doesn't have an m in it anywhere. And then the b is the y-intercept. We've talked about what an intercept is. That is where it crosses the y-axis. And we even learned how to find one. So let me just give you a quick example. And I'm just going to give you an example of a linear function. Let me use a different letter than, okay, don't want to make it confusing by using the same number twice. So if our function is y equals 4x plus 5, the slope is 4, okay? We haven't really talked a lot about slope. We're going to dive into that in a minute, but we already understand y-intercepts. This tells us that this line is going to cross the y-axis at 5. Well, yesterday we learned how to check that, how to know what the y-intercept is. We said replace the x with 0, solve for y. So in this case, that would be y equals 4 times 0 plus 5. And order of operations, say I do the multiplication first. 4 times 0 is 0. 0 plus 5 is 5. So you can see how that does work. The y-intercept is that number, that constant that's out at the end. Okay, let's dive into slope a little more. Make sure we understand a few more things about slope. So slope is, and we use that word in English, and we think of it as being something that either slopes downhill or uphill, right? So if we are talking about the slope between 2 points, we have a point here and we have a point here. And we have a slope that connects them. This would be an uphill slope, right? So the way that you calculate the slope, it's basically a measure of how steep it is. How quickly does it go up or how quickly does it go down? We measure the rise and the run. So I'm using the words first and then we'll get into the formula. So if we go from this first point over to the right to this point, we have to go up and we also have to go to the right. So I'm just going to draw in a triangle with a right angle here to where I do that whole difference in height first, and then I do the whole difference in how far it is to the left or the right second. Now it could be that we have to go down instead of up, or we have to go to the left instead of to the right, depending on where these points are. My example, we're going up, that is our rise, and then we're going to the right, and that is our run. And I like using those English words because I think that helps you remember that you do the height difference first. So that's what goes in the numerator of your fraction. And then the difference left to right is what goes in the denominator. So if you can just memorize that, slope is rise over run. It kind of has a ring to it. After you say it a few times, it kind of comes natural. And then you're going to remember what goes on the top of the fraction and what goes on the bottom. Now, when we're talking about a ordered pair, our change in how high it is the y. Remember, our y-axis goes up and down. So that is what we're going to do on top. We're going to subtract the y's. So we're going to take the y from one point and subtract it from the y of the second point. And that is going to give us our numerator of our slope. And then we're going to do the same thing in the denominator, but with x's. So let's just do an example. So in this problem right here, it says calculate the slope of a line through 2, -2, and 4, -3. So according to our formula, we're going to take the difference in the y's. We're going to subtract the y values in the numerator. So that's -3 minus -2. And then in the denominator, we're going to subtract the y's, or the x's. 4 minus 2. So in the numerator, -3 minus -2 is the same as -3 minus, or I'm sorry, -3 plus 2, which is a positive -1. I cannot talk today. And in the denominator, we're going to take 4 minus 2, which is 2. And I believe Blackboard, or I'm sorry, my math lab is going to have you put that negative out in front of the fraction. Whenever you have a negative in the numerator or denominator, just pull that out so it's a negative fraction. So the slope of this line that connects these 2 points is -1/2. Now, a question I always get here is, does it matter what order I subtract my x's and my y's? And the answer is no, but. And the but is that you have to be consistent. So if in the top I decided instead of taking the second y minus the first y, I took the first y minus the second y, that's okay. The y's have to go on top. You can't change that, but you can change the order. But the rule is if you change the order on top, you have to change the order in the bottom. So on the bottom, I'm also going to take the first x minus the second x and have 2 minus 4. So subtract on top, -2 plus 3 is +1. 2 minus 4 is -2. Notice that that is going to be equal to our same answer that we got before. Pulling that negative out in front, we get -1/2. Okay, so you're going to get the same answer. Just be consistent. What you do with the x's, you have to do with the y's. Okay, this next problem, we're going to do 2 things. Write the equation, so that's the first thing, and then graph the line with the slope of -1/3 and y-intercept of 2. Let me clean that up. Okay, slope is m and y-intercept is b. So this first part is actually pretty straightforward. We know the formula for a linear equation is y equals mx plus b. This tells us it's linear because it says the line. So to write the equation, we just replace the m with -1/3 and the b with 2, and we're done. So if this problem had only asked us to write the equation, that's it. We're done. But we are asked to graph as well. So when I'm graphing a line and I have it in, this is called slope-intercept form, by the way. The equation for a line can look different if you start adding things to both sides or multiplying or dividing. Whenever it's solved for y, it's called slope-intercept form. And when it's in this form, you want to start with the intercept for graphing because that is a single point that we know. We know that this line has to cross the y-axis at 2. So I just put a point at 0, 2 because that's my y-intercept. Now I know that the slope is -1/3. I can rewrite that as -3/1. Or I'm sorry, I said that backwards. -1/3. I wrote it right. So our rise is -1. So instead of going up 1 to get to my second point, I'm going to go down 1. Now we're starting at that point that we know. Go down 1. And then the run is 3. So now I'm going to go over 3. You have to do both of those 2 steps, and then you put your second point. So I started at my first point, down 1 for -1 is my rise, to the right because it was a +3. And I could keep doing that and put more points. Notice these are all going to line up, -1, 3. If instead you had put the negative in the denominator and thought of this as -1 over -3, it still works. Start at your point. This time you're going to go up. Your rise is positive, but your run is negative. Notice these all line up. So once you have a couple points, you need at least 2. I would recommend going ahead and doing a third one. It just makes it a little easier to draw the line. Hopefully yours is neater. If you have a straight edge or edge of a paper or something you can use to draw it, it's going to help you out. Okay, so there is my line. So now I have done the second half of this problem, which said to graph a line. Now out here to the side, I just made a little note that I think is important. You might want to jot this in yours as well. If you have a negative slope, as you go to the right, it's going to go downhill. If you have a positive slope, as you go to the right, it's going to go uphill. Okay?